Welcome to this comprehensive guide on implementing the factory pattern in Unity 3D for dynamic enemy creation. The factory pattern is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. In game development, this pattern is incredibly useful for decoupling object creation from the client code, enhancing flexibility, maintainability, and scalability. Imagine a pizza shop. You order a pizza, and the shop makes it without you needing to know the exact steps or ingredients for each type of pizza. Similarly, in Unity, a factory can create different enemy types without the spawner needing to know the specific class of each enemy. This centralizes the instantiation logic, making your codebase easier to manage and understand, especially as your game grows. Now, let's begin by setting up our Unity project for this tutorial. First, open Unity Hub and select New Project to start fresh. Choose the 3D Core template. Give your project a descriptive name like Factory Pattern Tutorial and select a suitable location. Once the project loads, we'll organize our assets by creating essential folders. In the project window, right-click and create a new folder named Scripts. Repeat this process to create prefabs and materials folders. This structured approach keeps our project tidy and makes navigation much easier as we add more components. Now, let's switch over to Visual Studio to define our enemy interface and concrete enemy classes. First, we'll create an interface named iEnemy to define the common behavior for all our enemies. Inside iEnemy, we'll declare a method signature, Void Attack. This ensures all enemies will have an attack capability. Next, let's create our first concrete enemy class, Goblin. The Goblin class will implement the iEnemy interface and provide its unique attack method implementation. We'll then create Orc and Dragon classes, each implementing iEnemy with their own distinct attack messages. These simple debug log messages will help us verify that the correct enemy type is being created and attacking. With our enemy types defined, it's time to build the core of our pattern, the enemy factory. Create a new C# script named Enemy Factory in your scripts folder. Inside this class, we'll implement a static method, createEnemy, which will be responsible for instantiating our enemies. This method will take a string parameter, type, to determine which enemy to create. We'll use a switch statement to check the input type string and return an instance of the corresponding enemy class. Remember to include a default case to handle unknown enemy types, perhaps returning null or throwing an exception. This enemy factory now centralizes all enemy creation logic, making it easy to add new enemy types later without modifying client code. Now, let's head back to Unity to create visual representations for our enemies. In the hierarchy, right-click, select 3D Object, and choose Cube for our Goblin. Rename this game object to Goblin and drag the goblin.cs script onto it from the project window. Repeat this for Orc using a sphere and Dragon using a capsule. Once created, drag each game object from the hierarchy into your prefabs folder to turn them into reusable prefabs. These prefabs are crucial. They're the actual game objects that our factory will help us instantiate dynamically. Now that we have our enemy prefabs, let's create a spawner script to utilize our enemy factory. Create a new C# script called Enemy Spawner in your script folder. This script will need references to our enemy prefabs and a way to trigger enemy creation. We'll also add a public string variable, enemy type to spawn, to easily switch between enemy types in the inspector. In the update method, we can add a simple input check, like pressing the space key to trigger enemy spawning. Inside this condition, we'll call enemyFactory.createEnemy to get an iEnemy object. Then, based on the enemy type to spawn, we'll instantiate the corresponding prefab at a specific location. For instance, if enemy type to spawn is Goblin, we instantiate Goblin prefab. Back in Unity, create an empty game object, name it Spawner, and attach the enemy spawner script to it. Drag your Goblin, Orc, and Dragon prefabs from the project window into their respective slots in the enemy spawner component in the inspector. Set the enemy type to spawn field to Goblin initially. Now, let's run the scene and see our factory pattern in action. Press the play button in the Unity editor. As you press the space key, Observe how different enemies are dynamically created in the scene. Change the enemy type to spawn in the inspector to orc while the game is running. Now, pressing space will spawn an orc sphere, demonstrating the factory's ability to create different types on demand. Repeat this for a dragon to see the capsule appear and its unique attack message. This dynamic creation, driven by the factory pattern, allows for flexible and scalable game design. To recap, we've successfully implemented the factory pattern for dynamic enemy creation in Unity. This pattern decouples object creation, centralizes instantiation logic, and makes your code more maintainable. For best practices, consider using enums instead of strings for enemy types. Enums prevent typos and provide compile time safety, making your code more robust. You can also extend this pattern to include more complex enemy initialization parameters. We encourage you to experiment by adding new enemy types, unique behaviors, and different spawning conditions. The factory pattern is a powerful tool in your game development arsenal, enabling cleaner and more scalable code. Thank you for joining us in this tutorial. Happy coding!